Hi, welcome to our math and my series of videos on finance equations. So Isabel just got her first job and she decides to put $40 a month away. And she found an account that pays 6% compounded monthly. This is a great idea to do. I don't give a lot of finance advice, but putting money away into a retirement account is great. All right, how much will she have in her account after 1 year? So this formula here is if you have one lump sum. I'm going to put $20,000 into the account and forget about it for a long time. This is a one and done. This one, however, this R, you can think of, this is not what it means, but you can think of an R as like repeated deposit. You repeat your money over and over and over and over and over. This 1 plus I is really just R over N, the same R over N that's right here in our lump sum equation. And this N is really meaning the same as NT. I don't know why some books do this N and sometimes do NT. It gets a little confusing, but just remember this interest isn't just being done 12 times, it's being 12 times however many years. Okay, so R is going to be $40 because that's how much she's investing. I'm going to write the first equation with all of these numbers in there, and then I'm going to show you as we move down how you can streamline the process. So she invests $40. We have 1 plus, we said I is R over N. To get R, we need to take the 6% and divide by 100 to get it into a decimal. So 0.06 divided by N, and is the number of times that 6% is applied. Well, no. Broken up into. So what happens is it's 6% a year, but that 6% is divided by 12 and that tiny chunk is applied each month. Because of that, you need to apply this whole calculation 12 times so that you get the full year. Because this is for 1 year, I don't need anything else there. Minus 1. And on the denominator, I have this I again, which is 0.06 divided by 12. This is kind of a hunk of chunk to put into your calculator. But if you do it correctly, you end up at the end of 1 year, she has $493.42. Awesome. So if a lot of times when we think about things, we're like, oh, 1 year to 10 years. After 10 years, she should have just under $5,000, right? Well, let's calculate it out. So A is equal to 40. And we still have 1 plus 0.06 divided by 12. But now instead of 12 times, it's 12 times a year for 10 years. So I actually have to multiply this 12 by 10. Into the denominator, I want to take this 0.06 divided by 12, and I'm going to just divide it out. I'm going to simplify it. So all I need to put down here is 0.005. It helps when calculating on your calculator. Anything you can do to simplify it. You could leave it as 0.06 divided by 12. You'll get the same answer. This is just a little bit easier to look at. But after 10 years, she has $6,555.17. Notice we're rounding to 2 decimal places because that's what we do with money in this country. Okay, so if she lets her account go until she retires in 40 years, how much will she have? So once again, the only thing that's changing is this 12. So A is equal to 40. I'm going to get this 0.005 in. 1 plus 0.005. You could also write 1.005 and make it even cleaner. 12 times a year for 40 years minus 1 divided by 0.005. And after 40 years, she has made $79,659.63. But the real question, depositing money for 40 years for retirement is great. And if you just put that $40 in a month, and 6% is pretty small for a retirement percent. Oftentimes, if you go to a finance place, so you can get like between 8 and 12, and that will really make a huge difference. But what if you're doing a smaller time investment and you're like, well, I just want a down payment for a future house. She just graduated college. She figures she needs about 8 years to get a house. And she wants to have a down payment of $5,000. So how long until all this happens? So this time we want $5,000 and we're still putting in $40 a year. No, we don't know what she's putting in the year. This time we're calculating how much she needs to invest. So instead of saying, hey, I'm just going to put $40 away, the question is, how much do I need to put away each month so that in 8 years I can get this house? The rest of the numbers are going to be the same, so I'm going to streamline this again. It's going to be 1.005 to the, well, let's even make this better. N equals 8 times 12, which is 96. To the 96 minus 1 divided by 0.005. So I'm not going to calculate this out. I'm going to divide both sides by this big hunk of 1.005 to the 96 minus 1 divided by 0.005. Don't lose all of those zeros. Divided by blah. These guys cancel. We find out that what she needs to invest each month for 8 years to have the down payment she wants is $40.71, which is only a pinch more than she was already investing. Okay, I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!